Tools for structured system analysis and design. Sixth one, system flowcharts. There are two types of system flowcharts: information-oriented system flowcharts and process-oriented system flowcharts. First one, information-oriented system flowcharts. Information-oriented system flowcharts use a grid structure to trace the flow of data. They identify input data and follow its flow until its subsequent appearance as output information. They do this by identifying specific data carriers. They do not identify processing operations. This figure is an example of information-oriented system flowcharts. In this figure, it shows how data, filled out forms or an electronic image flow across horizontal boundaries. The storage of hard copy data is indicated by use of offline storage symbol. This figure is an example of customer billing system. The first portion shows a point of sales terminal is used to capture sales and payment data that is transmitted to data processing. Sales slips and payment slips are produced in duplicate. Second, the original copies of sales slips and payment receipts are given to the customers. Third, the second copies of sales slips and receipts are sent to accounting where they are retained for future reference in files. Fourth one, sales summary data is formatted and is available for display. Next one, guidelines for drawing information-oriented system flowcharts. There are a few simple steps in drawing information-oriented system flowcharts. The first step is to identify all groups or departments that are involved within the system. The names of these groups or departments become the headings across the top of the chart. Second step is to draw a symbol for each output of the system in the column under the name of the group or department that creates the output. In an automated system, that will usually be in the column identified as data processing. For a logical flowchart, use the generalized input or output for flowcharting symbol for all outputs. If the flowchart is to show a physical implementation, use the document symbol for all hard copy outputs and the display symbol for all soft copy outputs. The third step is to draw a symbol for each of the system inputs. Use the same symbols as in step 2. The symbol should be placed in the column that represents the group or department that originally records the input data. The last step is to show where groups or departments use the information. If the use of the information is merely to file a copy of a form, the offline storage symbol is used. If the use of the information is for purposes of data verification, management decisions, etc., the document or display symbols are used. Next one, process-oriented system flowcharts. Process-oriented system flowcharts, commonly referred to as system flowcharts. They show which data processing operations are converting inputs into outputs. These flowcharts can be drawn to any appropriate level of detail. The highest level and the least detailed flowchart is called a high-level system flowchart. Lower level of detail are represented by expanded flowcharts, which are referred to by names such as intermediate level and detailed level. They can be used to provide a logical description of the system by using only the basic symbols or a physical description by using the system-related symbols. This is an example of high-level process-oriented system flowchart. System flowcharts have a characteristic sandwich structure. Figure shows the basic sandwich structure. Charges and payments are the bread of the input data. The billing program is the filling of the processing operation, and the customer bills and summary is the bread of the output data. Process-oriented flowchart should also be accompanied by a narrative. Many flowcharts are too complex and too detailed to accommodate the narrative on the same page. There are three types of process-oriented flowcharts: high level, intermediate level and detailed level system flowcharts. First one, high level process oriented flowcharts, study phase. These flowcharts are very valuable at study phase reviews. The participants in these reviews usually are not data processing professionals. Elimination of confusing detail in the flowchart helps to highlight the user-oriented characteristics of the system. Second, intermediate level process-oriented flowcharts. Design phase. These flowcharts identify the specific inputs, outputs, and processes in considerable detail. Third one, detailed level system flowcharts, development phase. These flowcharts precede the construction of computer program flowcharts by programmers. They identify the inputs, outputs, and processing operations for each of the computer program components. Detailed control operations are also shown.